All right, we've done it. We have reached the end of our identity sheet. So if you look, right, we have covered our basic identities, our Pythagorean identities, our sum and difference identities, and now we're on to our double angle identities. Our double angle identities is that sine 2x is equal to 2 sine x cos x. It's a really easy one to replace, but that cos 2x has three choices, and we have to decide which one it is that we're going to use. And then tan 2x has two options as well. You can replace it with 2 tan x over 1 minus tan squared x, or you can replace it with sine 2x over cos 2x and then use these identities after that. It's kind of up to you. So we're going to start using our double angle identities to simplify. So this first question says sine 2x over cos x. So the sine 2x has no choice. This is going to be 2 sine x cos x over cos x. And then the cos x's can simplify, and I'd be left with 2 sine x. The cos 2 theta identity is a little bit trickier because remember we have three choices. We can choose cos squared theta minus sine squared theta, or x, 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. When I look at this one, when I'm choosing, often there's something else in the question that will help me decide which one I'm going to choose. When I look at my denominator here, there's a cos theta minus sine theta, which makes me feel like this one might be the right choice. So I'm going to replace the cos 2 theta with cos squared theta minus sine squared theta. And now I'm over cos theta minus sine theta. Well, why did that help me? And a lot of people might be like, look, you can go cos squared theta minus, or divided by cos theta is gone, and sine squared theta minus sine theta is just sine theta. Woo! Don't do that, please. So why? Because there's a minus sign here. Cos squared theta minus sine squared theta before you can start dividing. Cos theta minus sine theta before you can divide into. So you cannot simplify. But what we can do is notice that our numerator is a difference of squares. I start seeing differences of squares everywhere. Like for example, if I look at my formula sheet, when I see cos squared x minus sine squared x, I see a difference of squares. When I change this one around as cos squared x equals 1 minus sine squared x, I see this as a difference of squares. They're just kind of all over this formula sheet. And so this one I'm going to factor as cos theta minus sine theta times cos theta plus sine theta all over cos theta minus sine theta. Why? Because now I'm allowed to simplify. Cos theta minus sine theta divided by cos theta minus sine theta times cos theta plus sine theta, right? Now I can do that order of operations, would leave me with just cos theta plus sine theta. And we will call that simplified. All right, now we're going to move on to focusing on the cos double angle identity when there's this kind of trick I call eliminating the 1. So what you'll notice is anytime there's a cos 2 theta identity, often there will be a 1 accompanying it. So for example, it could be 1 plus cos 2 theta, or it could be 1 minus cos 2 theta, but there'll be this like external 1. And why it's there is because they're designed that if you substitute in the right double angle identity for cos, that the 1 will go away. So if I bring up our formula sheet, oh, not that one, sorry. Where's our formula sheet? This guy. Okay, if I bring this one up and I want to eliminate the 1, I've got two choices. So for this one, I have to choose, there's three choices, but there's only two that have 1s in them. I have to choose 1 minus 2 sine squared x or 2 cos squared x minus 1. Because this has a plus in it, if I choose the 2 cos squared, always check what this is, theta, minus 1, when I collect like terms, I have 1 minus 1 and it's gone, and I'll be left with 2 cos squared theta. And so it just makes things simpler. When you have one like the next one, 1 minus cos 2 theta, this time we're replacing the cos 2 theta after a minus sign. The minus is going to change the sign of what's ever in here. So if I had chosen this guy, I'd go 1 minus minus 1, which would make you add it. So instead we're going to choose the 1 minus 2 sine squared x, so 1 minus 2 sine squared theta in this case. And now when I distribute that minus sign through, I get 1 minus 1 plus 2 sine squared theta, and the 1's will go away and I'll be left with 2 sine squared theta. So it can just be really helpful to keep that in mind, that when you're substituting in for cos 2 theta identity, there'll be some clue in the question. Maybe it'll be a 1, or maybe it'll be something like a cos theta minus sine theta in a denominator. All right, let's try a couple questions where they might be a little bit harder. So this first one is a question that comes up in the trig identities, so lesson 2. And when I first saw it, I was like, what is going on? Until I saw that repetitive pattern, cos cos, sine sine. And that made me think of what? Well, let's go to identity sheet. If you look in your sum and difference identities, you've got a cos cos sine sine with your cos sum and difference identities. So what are we going to do? Well, the first thing we have to do is not have a minus out front, because none of these identities have a minus out front. So the first thing we're going to do is factor that out. So we're going to have 1 minus bracket. If I divide both of these terms by -1, I get cos 5 theta cos 3 theta plus sine 5 theta sine 3 theta. Okay, now what? Well, I know it goes cos cos sine sine, so I'm going to be replacing it with one of these sum and difference identities. Now, because I have the plus, that means I'm going to choose the difference identity. So I'm going to replace this with cos of the first angle minus the second angle. So I'm left with 1 minus the cos of 2 theta. Then we're up to here, right? I want to eliminate the 1. So which one am I going to choose? Well, I'm going to choose the one that has the positive 1. So 1 minus 2 sine squared theta, which will leave me with 1 minus 1 is gone, and then negative negative makes that 2 sine squared theta. Right? So incorporating our sum and difference identities in a backwards way, as well as our double angle identity. All right, last question in this lesson. So again, we are going to replace all of our double angle identities. We have some sine 2x's and we also have some cos 2x's. What are we going to do? Well, first off, the sine 2x's are really easy to replace because there's only one option. 2 sine x cos x. Then here I've got a plus, and I'm going to replace it. And on the bottom, I'm going to do the same thing. So 1 plus 2 sine x cos x. And then I've got minus what? Well, look for the eliminating the 1 trick. This is a 1 plus, so I want to look for the one that's going to subtract 1. So for this one, I'm going to put in 2 cos squared, oh, I get to replace x, minus 1. And then on the bottom, I'm subtracting, so I want to put the positive 1 in. So I'm going to put 1 minus 2 sine squared x. And then we're going to see where this goes. Okay, so sometimes having a trick just allows you to do other things. So for this one, I hope you can see that I'm adding. So I've got the 1, I guess I don't have to make my circle that big. I've got the 1 and I'm taking away 1, so that's going to be gone. So in my numerator, I'm going to be left with 2 sine x cos x plus 2 cos squared x. And then what about my denominator? Well, maybe we should distribute through, you think? Or can we do this? You've got 1 minus 1, so that's gone. So I'm left with 2 sine x cos x. And then I've got minus negative 2, so plus 2 sine squared x. If I jump too many steps, put them in, right? Show yourself multiplying a plus 1 through and a minus 1 through, and then collect like terms. Now I'm at a point where I can't simplify anything. Even though these are identical, I have to add before I can divide. So I'm going to look for a greatest common factor. Out of the top, I can take a 2 cos x, and I'm left with sine x plus cos x. And in the bottom, what can I take? I can take a 2 sine x, and I'd be left with cos x, plus sine x. Magic. Let's make this bigger. Okay, keep going. What can I do now? Well, I can simplify the 2's, right? So 2 divided by 2 is 1. And then sine x plus cos x divided by cos x plus sine x is also 1. So then I'm left with cos x over sine x, which to me is a great answer, but I could also replace this with our quotient identity of cotan x. Whoa. Lesson 1 is a doozy. I doubt we will ever make it through this in one day, but it's everything you need to know. If you can slowly go through lesson 1, all of these videos, lesson 2 is going to be a breeze. I think what's going to happen is that we're going to do these over 2 days and trig identities over one day. Good luck.